Guys, today we are going to see an interesting IoT project named cold storage monitoring. This is the overview of this today's video. We will be going through introduction, problem statement, justification for the design, components used, system architecture, UI UX design, and finally business model canvas. Getting into the introduction part, cold storage monitoring is essential for industries that store perishable goods such as food and beverages, pharmaceuticals, chemical and research labs. There are many examples in it. Challenges in traditional cold storage monitoring will be resolved in this project. Managing cold storage efficiently is a major challenge for business dealing. Issues like temperature fluctuations, inventory mismanagement, high energy consumption, and compliance with safety regulations can lead to significant losses. In this video, we will explore how innovative solutions can help improve efficiency and reduce waste. To ensure an efficient and reliable cold storage monitoring system, the proposed IoT-based solution is designed with the following key justification. First one, real-time monitoring using IoT sensors and automated alerts and notification for critical changes, cloud-based storage for data logging and analysis, remote access via web dashboard and mobile app. We definitely need three sensors in this IoT project. DST22 or SST31 measures temperature and humidity with high accuracy. The next one, DS18B20, a waterproof high-precision digital temperature sensor, which is extremely used for cold environments. And CO2 sensor ensures air quality by detecting harmful gases. And why we need these sensors? These sensors provide continuous real-time monitoring and prevent spoilage. ESP32 has been used in this project. A low-power, high-performance microcontroller with built-in Wi-Fi and Bluetooth connectivity. Why it is used? ESP32 ensures efficient data processing and real-time transmission to the cloud. It reduces the traffic to the network cloud and also it processes the data quickly. That's why it is used. And now coming to the system architecture. Here we have used a layered approach where it ensures real-time monitoring, cloud storage and remote access. The first layer is called as device layer, where it contains all the sensor components which collects the environmental data like DS22, DS18B20 and CO2 sensor. And coming to the next component, edge layer. Here it mainly contains ESP32 microcontroller, which connects the sensors and processes readings and prepares data for cloud transmission. And the third layer, cloud layer, which contains the ThinkSpeak component, which stores the real-time cloud storage data. And also AML integration, predictive analytics for cooling system efficiency. Finally coming to the last layer, that is called as application layer. In this, we can see the output data in the web dashboard and mobile app and also through new notifications. The web dashboard is made up of React.js and mobile app is made up of React Native, and using notifications, that is through email, SMS and mobile alerts, sends instant warnings when thresholds are exceeded. And next we are going to see the UI UX design of the cold storage monitoring system. This is the web application of our cold storage monitoring. We have launched this web application in netlify.app and you can check through it. I'll also give the link in the description. Now this shows the average values of the temperature, humidity and CO2 which have been measured through the sensors. And these three shows the live data which has been recording in the sensors. That is the temperature, humidity and CO2 level. And it can also be seen through the graphs. Here the environment analysis shows the graph, that is according to the time variation it will be displaying the values of the temperature, humidity and also the CO2 levels. That too can also be compared with other graphs and other data values. This shows that the system status has been active and the sensors are already working, and if there is any alert message, it can be seen through this dashboard, that is alerts overview. Here we can log in. Now moving to the control panel. Here there are device controls like system power, connection and advanced settings. Once we switch on the system power, it will be cooling down the machine. And we can connect the cold storage device with this thing, where we can connect or disconnect. And here in the advanced settings we can configure, that is the temperature sensor pin and cooling relay pin or any other sensor pins can be change and process further. And the control mode. In this control mode, we can turn on and off, and we can manually adjust the fan speed, that is the cool air speed, manually through this thing. Now coming next to the temperature threshold management. Here we can set the minimum temperature as 18 degrees Celsius and setting the maximum temperature as 26, 25 or 28 degrees Celsius. After setting, once the temperature exceeds this maximum temperature or minimum temperature, we will immediately get an alert message. Now let's see through the input settings. It is same as the threshold management system, where the temperature threshold can be set here and can also be saved. And same as the temperature threshold, we can also manage the humidity threshold and also the CO2 threshold. Once if there is an exceed or any other abnormal movement in these sensors, you will get an alert message manually through email or push notification. In email notification, you can enter your email address. Sorry, we will be getting a mail on the alert message, or push notification, that is SMS. Now, the advanced settings, the reading interval. The reading interval can be updated once 5 minutes, 1 minute or any other 15 minutes according to your preference. Now moving next to the alert part. Here the alert messages are listed out, where you can see there are different types of alert messages like main control unit, server room, power supply unit. These are different sectors, and the alert message is high temperature, temperature warning, high temperature. There are many different other type messages, and the status of the message can also be viewed, where acknowledge, the sum of the status of the alert messages have been acknowledged or active, and also resolved. Next, we can also download the data which have been entered for 15 minutes as a CSV file. Here we can see the data with timestamp, temperature, humidity and CO2 data. According to the timestamp mentioned, the data have been recorded and it can be viewed as CSV file, but we can also download it in an Excel sheet. It can be helpful for further readings. And finally coming to Arduino Uno, which reads temperature from an LM35 sensor and controls a fan using serial commands. Let's break it down. First, we define our temperature sensor pin on A0. In the setup function, we start the serial communication at 9600 baud and set the built-in LED as an output, which will act as our fan indicator. In the loop function, we read the temperature sensor value and convert it into voltage. Then we apply the LM35 sensor formula to calculate the actual temperature in Celsius. This temperature value is printed to the serial monitor. Next, we check if there is any serial input. If we receive the command fan on, we turn on the built-in LED to simulate the fan turning on. We also print fan on to the serial monitor. This is a simple but effective way to monitor temperature and control devices using an Arduino and a serial interface. If you like this project, don't forget to like, share and subscribe for more Arduino tutorials. See you in the next video.